My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 610. In this lecture, we will try to understand max pooling. In lecture number 607, we discussed about pool. Just try to recall. We saw something called as pooling layer. Let's understand what is the pool means. This pool is called pooling actually. Let me explain what is pooling. We will try to understand what is pooling. Pooling is a layer that we can add, isn't it? Before we saw how it works, let's understand what is the inspiration. What is the inspiration for this? What is the inspiration for pooling? The concept is, imagine I have my image here, my raw image here. I apply a kernel on top of it. What is my kernel? K cross C. So let's assume this is my matrix size is, my kernel size is K cross C. Then my matrix size is N cross C. I get an image, isn't it? I am getting this particular image. I have image whose size is N cross C, and I have a kernel whose size is K cross C. Now I get an image. I have not yet applied anything. Let's assume I do enough padding and stride s equal to 1. Here let's assume I have got, what is this output size? Let me assume this image size is, this output size is, assume I have got N cross image, isn't it? Let's assume this is detecting some vertical edges. Yes, let me assume this is detecting some vertical edges. Let's assume I have got an image like this. I'm just writing it down. Let's assume I have got 1 here. Yes, which means an edge present here. Let's assume I have got 0 here. I have got 1 here. Let's assume I have got 0 here. So some 1 here, some 0 here, isn't it? So actually, let's assume I am having these values, isn't it? So what happens is, what it says, let's assume this kernel, let's assume this kernel detects vertical edges, isn't it? Remember, it is hard code kernel. What type of kernel it is? It is hard code kernel. It is a learned kernel. It's already learned kernel, isn't it? Let's assume that learned kernel, what is the functionality of this learned kernel? This learned kernel detects vertical edges, isn't it? Now one of the things we wanted to do is, we want our models to be something called location invariant, isn't it? We want our model to be location invariant. What is the location invariant means? Suppose, let's assume we are trying to detect an object. Let's assume in this particular image, I am trying to detect an object in this image, in this raw image. Otherwise, the object is here. I can say the object here is face, isn't it? Face. Whether the face is here or the face is here, I would like to detect. I would like my convolutional neural network to detect the face. It need not bother whether face is here, whether face is here. Your convolutional neural networks must detect, isn't it? That is known as, I would like my convolutional network to detect whether the face is, wherever the face is. Actually, your face is here, wherever the face is. Wherever the face means what? Whether face is here, your convolutional neural network must be able to detect. I would like my convolutional neural network to detect there is a face here or here. Whether the face is here or here, your convolutional neural network must detect. It doesn't matter. That is called, it doesn't matter where it is. Your CNN must be able to detect, isn't it? Is called location invariance. This concept this concept that wherever that phase is, we should be able to detect, isn't it? Wherever what is the location invariant, wherever the phase, wherever the object in this image, we should be able to detect. Your convolutional neural network must be able to detect. This is called locational invariance. There is also something called as something called as scale invariance, isn't it? Which means whether the phase is small, just see, which means scale invariance means what? Whether the phase is small, something like this, whether phase is big, isn't it? Scale invariance, which means whether the phase is small or the phase is large, I would like to detect it. Your CNN must be able to detect it. There is something called rotational invariance, isn't it? Which means, what is the meaning of rotational invariance? Whether the phase is like this, whether the face is like this, or face is tilted like this, isn't it? Face is tilted like this. I wanted to be able to detect this. So pooling is a concept that makes your model slightly invariant to all these transformations, means location, scaling, and rotation, isn't it? The way it does is, I will explain you how it does, and the way it does is very interesting. So it's try to make the inspiration, it comes from biology. In biology we have some neurons, isn't it? In biology we have some neurons, especially at the higher levels, not in V1, not in V2, but in higher levels like V7, wherever the face in the input image, isn't it? Wherever the face in the input image, face could be here, face could be here, isn't it? Face could be rotated, isn't it? Like this, face could be rotated, face could be scaled. Still this neuron in V7 fires, isn't it? Still the neuron in V7 fires. So there is a single neuron or small set of neurons that are firing as soon as see a face. Wherever the face is, however the face is smaller or larger, okay, that's what it happening in biology. So people said, can we somehow replicate that which is happening in biology? Can we replicate in mathematics, or can we replicate in CNN? That is the inspiration for pooling, and the way pooling works is very simple. So imagine if you have image like this, very simple concept. Let's assume I have 4x4 image like this with values. Let's assume this is 4x4 matrix, isn't it? 4x4 image. On top of it, what are the values in this image? Let me assume I have values 1 2 4 5 6 7 8 3 2 1 0 1 2 3 4, isn't it? Let's assume this is 4x4 image. On top of it, let's assume we want to perform max pooling with kernel or filter size equal to 2 with stride equal to 2. I want my max pooling with kernel size 2. Max pooling is also like kernel, isn't it? You can think of max pooling as doing some sort of kernels. You can think of it as a kernel. You have a kernel of size 2, isn't it? You have a kernel of size 2. The max pooling kernel, what it does is, it says I take this 2x2 filter, just see this 2x2 filter, and I find the maximum value. What is the maximum value here? 1156. What is the 2x2 filter? 1156, which is the maximum value 6. The resultant here is 2 cross 2 matrix, because my max pooling kernel, max pooling filter or max pooling operator has size of 2. So I will take 2 cross 2 matrix. You take the maximum value of all of them. So I will put, what will I put? I will put 6 here. Why? Because 6 is maximum of 1156. 1.56, isn't it? Now I said my stride equal to 2, so this is done. So my stride equal to, I want to go the stride equal max of 156 is 6, isn't it? As my stride equal to 2, again which one will I take? 2, 4, 6, 7, 8. What is the maximum value of 2, 4, 6, 7, 8? That is 8, isn't it? I jumped by 2 units. As stride equal to, as s equal to, I jumped by 2 units, isn't it? Yes. For the, what is the maximum value here? Maximum value for second 2, 4, 7, 8 is 8. Next 2 by 2 matrix. Which one is next 2 by 2 matrix? 3, 2, 1, 2. What is the maximum value here? 3, 2, 1, 2. Maximum value is 3. What just I am keeping in resultant matrix, isn't it? What is the maximum value here? 1, 0, 3, 4. 4 is the maximum value, isn't it? And this is how the max pooling layer works, with a defined kernel size and very simple stride. Now what happens? Max pooling with kernel size equal to 2, kernel size equal to, and stride equal to 1. Let me assume like this, that then I get 3 by 3 matrix, isn't it? What is the maximum here? Maximum value of 1156 is 6. Again 1267 is 7, isn't it? Because my stride equal to 1. Just see. But 2, 4, 7, 8, maximum value is 8. In similar manner, I can fill all the values. Then what is the resultant matrix? Is 6, 7, 8, 6, 7, 8, 3, 3, 4. So max pooling basically says, take the kernel, but you are not multiplying the kernel with anything. Remember, you are not multiplying the kernel with anything. You are just saying, you are simply saying, whatever the maximum value, put it in resultant matrix. You might wonder, how does max pooling creates invariance for you, isn't it? The concept is this. Let's take a 4 by 4 matrix here. So how does max pooling creates invariance? Let's assume I choose, let me say, I choose my kernel size equal to 2 and s equal to, what is my s? S means what? S means stride equal to 2. So what did we do? The first step, I took this. Which one? I took this one, first 4 cells, isn't it? Output from previous, this is output from previous stage. If this is an edge detector, I am assuming this is an edge detector. If there is an edge here, isn't it? If there is an edge here, you have high value here, because we said white is high value, dark is low value, or vice versa, isn't it? So if you have an edge here, let's assume we get a value here. So whether the edge is in this pixel, 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 isn't it? We are taking maximum value among all 4 of them. Now this value becomes, as maximum value 6, this value becomes 6, will be higher. Whether the edge is present, in this pixel, in this pixel, in this pixel, your maximum value, what is your maximum value is 6, isn't it? That's what it says. Similarly, let me consider another one. Just see this one, 4. Similarly, if you take this value, what is this value? I am considering this value 4, isn't it? This value is high. The edge would be present. In this pixel, in this pixel, in this pixel, isn't it? In any edge would present in any of these 4 pixels. If you have an edge, this will fire up. Which one will fire up? This 4 will be fire up. So it is a higher value, isn't it? So max pooling is saying whether you have edge here, whether you have edge here or here, isn't it? I can do your maximum value I will keep here, isn't it? Maximum value will be fine. I can do one more level of max pooling. Let me say I can do one more level of max pooling on top of it. If I do one more 2 cross 2 pooling on top of it, with k equal to, what do I get? 1 value. What is that 1 value? 8. That is 1 cross 1. So if there is an edge if there is an edge anywhere in this 4 by 4, doing 2 levels of max pooling, but by just doing 2 levels of max pooling, whether the edge is anywhere in these 16 pixels, that's important, whether the edge is anywhere in these 16 pixels, that's important, whether the edge is anywhere in this 16 pixels, this value 8 will always be high. This value will be high if there is an edge in any of the 16 pixels. By extension, if there is a phase in any of these regions, of the image, this value 8 will be higher, isn't it? It is actually creating location invariance. Your max pooling is a sort of location invariance, because whether your face is here, here, isn't it? Whether face is wherever it may be, it will still detect the face because it is taking maximum activation of each of these values, isn't it? What is this 8? 8 is maximum value of all these 16 values. That point is important, isn't it? Max pooling is very, very popular method in modern coordinates. There are also some old coordinates where people used average or mean pooling, isn't it? Average or mean pooling, where instead of like max in kernels, it's average or mean pooling. There is actually, I can say which one is most popular. This one is most popular approach. Which one is the most popular approach? Max pooling is the most popular approach, isn't it? We can actually you can say max pooling. What is the use of max pooling today? The most popular approach is max pooling. Max pooling is something like everybody using left and right. Very, very simple concept, which introduced invariance to the system, isn't it? That's important. Yes. If you observe carefully, what are the important concepts? Now we have all the components for coordinates. We have operations of convolutions. We have operations like, what are the components? You have components like convolutions, ReLUs, and max pooling, isn't it? These are I can say these are the most used components in any modern convolutional neural networks. I request all of you to go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.